Welcome back everyone. It's good to see you back here again. In this session, we're going to go into this topic called truncating the dendrogram. Now, before we go into that, it's paramount that we understand what the hierarchical dendrogram is. So just a little bit of recap. What we covered was in the first session really is talked about what unsupervised learning clustering is about and the uses of it. And then we go into the so-called Ward's agglomerative hierarchical clusterings, where there are two types. There are the agglomerative, which is bottom up, and then there is the divisive top down. And then we talked about the methods, the distance, how you actually calculate the so-called clustering method that is used, which from single complete all the way towards. So in our context, what we did make use of is the Ward's method, and that's where I want to come down to this chart here. Remember, this is a so-called bottoms-up method. So what you have here is literally, these are the so-called clustering of them. So let me come back up here. All right, so in essence, what it actually is doing is this. So let me just bring out the, plotting 2. So when we actually is calculating, in essence, what it actually is doing is that it's calculating all the distance between the dots. You know, you have 2 dots here. All right, so and then you have 1 dot here, and it actually tried to actually bring these together based on the distance itself. And you have a few that's on the other side, so it actually is doing exactly the same thing. It is clustering them together based on the distance. So what you have really is an exercise whereby it is actually doing the distance calculation for all of these dots, all of the so-called dots itself. So you have one green one, one red one, another red one, another teal, another teal. So if you really count it, there's like 1, 2, 3, 4, 5. And really what this is actually saying is that these lots are very close together, and these lots are very close together, and then likewise over here. Let's take a step back. I don't think last time I really go into details of how do you read the hierarchical clustering dendrogram. And on the x-axis, this part here, it's called the label. Now you can't really read anything into this. The x-axis is really the actual label itself, but you don't specify anything in this case. It's basically x1, x2, x3. It doesn't actually have a name because it's unsupervised learning here. On the y-axis, this portion here, this is where you see the distance. And the method that we use to calculate the distance in our case is the Ward's method, or the Ward's distance. Now, the vertical line, this one here, tells you the actual distance itself. And so when you actually look at these, which is really close together, it's saying that they're actually very close together. And then you have these horizontal line that tells you that these cluster and these cluster merge together. So if you think about it this way, is that there are lots of small dots that's actually really close together. Basically, they are close neighbor, so they will have very tight distance. I guess if you think about it in an apartment setting, you have the same floor, they are very close to each other. Hence, you have them very close to each other. And then you have another level of residents whereby there are like maybe 10 or 12 families close together. And then you have another 10 to 12 families close together. Now, because they're also very close together, maybe they're all within the same apartment or the same condominium. And this is probably the next doors or the opposite condominium, and this is maybe another opposite one. So if you think about it this way, that's really the whole neighborhood itself. And that's basically telling you how far is it from this floor to this floor, and then from this apartment to the next block of apartment. Maybe from here to here is probably another city, as an example, just to give you some picture on how to read that. The horizontal line is an example of when clusters merge together. So you have the green one here, the red one here, and then the teal one here. That's when the two clusters merge together. And then the vertical line tells you which clusters or which labels are part of the merge forming a new cluster. So you have these and these merge together, and you have this and this merge together. So these actually merge into one big clusters. And the heights of this, or heights of this so-called vertical line tells you about the distance that needs to be bridged to form the new clusters. So if we read it this way, from the red clusters to the teal cluster, in order for them to merge, from the red needs to actually go from here to here, which is from, I don't know, 160 down to 40 here. So it's about 120 is the distance. For the teal, is probably what, 70 all the way to 160, so as an example. Now that we've established that, there are a few ways to actually do this. Okay, so let me just come down here with the truncating of the dendrogram. Obviously, we don't want to have, well, here you probably have hundreds of clusters. That doesn't make any sense. So what we can do is actually plot horizontal line. And the question now is, I'm going to set the color to black. The question now is, where do I draw the line? So let's just try 175. Okay, so this is to visualize this. So when I draw that line at 175, and what you have now is 1 and 2 clusters. When you think about it, it doesn't actually make much of a sense when you have 2 clusters when these are really, really far apart. How far apart are they? So it's 175. You know, basically 175 to, I think that's roughly 40 there, so it's about 135. Maybe a distance that make more sense is probably 75. So let's just try 75. By the way, someone asked me, why do I actually have a semicolon here? The reason being, when I actually don't put the semicolon, I get this line here. When I put the semicolon and I run it again, I just want to squelch that line. Notice that that line of printout is gone now. It's just ugly. That's all. It's not a necessity. It's just something that I don't like to see when I'm actually running my code. It just makes it really ugly. So if I do 75, what I now have is 1, 2, 3 clusters now. And then that makes a little bit more sense. Maybe I'll try a little bit more and try 25. And wait for that to come out. And if I cut that line, what I would have now is 1, 2, 3, 4, 5, 5 clusters. And possibly that makes a little bit more sense in terms of what we are aiming to do here. So let's just try a little bit of truncating. Now, obviously, if you have all of these so-called leaves here, it's a little bit untidy. So I'm going to try doing this. Actually, I'm not going to type all that. I'm just going to type this out. And again, I'm just going to dendrogram. So I'm going to do this. Distance is what we calculated earlier using the linkage. We're going to do a truncating mode and STP. Okay, I will come back to that. P is equal to 6. We want 6 clusters, and the leaf rotation, okay, is equal to 0 degrees, and then the leaf font size is make it 12 points, and then we're gonna show the contracted is equal to true. Right, so let's just run that. What's show contract contracted? Okay, right, now notice that it's been truncated. It's no longer as messy or as big as that. What we now have is 1, 2, 3, 4, 5, 6, as we have specified here. P is equal to 6, and that is how you actually truncate the hierarchical dendrogram. Now, having done that, the next thing we need to do is actually retrieve them. What do I mean by retrieving? What we've done is actually, all right, we've gotten 6 clusters here, but we need to label them. So basically, we need to actually somehow label each of the dots or observation with the actual class itself based on these. So this might be 1, 2, 3, 4, 5, 6. So we need to somehow actually give it a label. Now, the good thing is Python, as always, have a whole bunch of libraries that you can actually make use of this. first of all, I'll just put some reference for you to look at, for you to go back to. The function is called f-clusters and is actually built into the SciPy itself. So scientific Python dot cluster, and also hierarchical hierarchy, and import the f-cluster. And then the maximum distance is equal to 25. So what I did earlier is to specify the number of so-called clusters I'm looking at. But now I'm specifying the distance. The distance here is 25, so I'm going to get 5 clusters now. So maximum distance is 25. So the clusters is equal to the f cluster, and distance, and then the maximum distance, and then the criterion is equal to distance, and then clusters. So this last part basically asks Python to print out all the cluster labels, so you have 1 to 5 here. So if we look at what we had earlier, if I want 6 clusters, it's a little bit tricky to get 6 clusters out of these. Yeah, you will have to find a distance that actually makes that work out, and it's a bit tricky basically by visual. I find it difficult to actually spot this. What if we actually specify 150? You know by now, if I specify 150, that should be 3. So let's just check our intuition to see if that is indeed correct. So what I should see is 1, 2, and 3, and nothing more than that, and which is exactly what we observe here, and that's really the point of that exercise. So let's leave it at 3 clusters, and we're going to plot that. So let's just plot, and we're going to set the fixed size first. Fixed size, we're going to set it to 10 by 8, and plot the scatter graph. Scatter plot 0 x, and plot everything in the row, and 1, and C is equal to cluster. Cluster is what we just specify here. That's this one here. This is the clusters, which is the label that we just created. And I'm going to use this color called prism, and we don't need to show. So let me just do a semicolon. Okay, what is the error message here? So unknown C map. Okay, C map. Okay, and this is what we have. We have 3 clusters. Which makes sense because you have these 2 are very close to each other, these 2 are very close to each other, this is very far apart, hence you actually have 3 cluster, with these 2 cluster being green and these 2 cluster being orange, and red is on its own. Now we know, looking at that, we basically want to actually have 1, 2, 3, 4, 5 clusters, and earlier we know that the distance to do that, to achieve that, is to actually have 25. Okay, all right, 25, run that, and then look at our visualization. And what do you have? You have 5 clusters with 5 different colors, and that's basically how you actually identify the actual clusters. First by calculating the distance, followed by truncating it using your intuition, and finally you can only do this when you actually have 2D, all right? Only have 2 so-called 2-dimension. Okay. Now earlier what I showed you is by distance, correct? By the maximum distance here. So I'm gonna label this 1, 2, 3 by distance. Now obviously it's difficult to use visual, so the other way is to by clusters. So I'll just say by clusters. Now how do you do it by clusters? So I'm going to specify first of all clusters is equal to 5. Clusters is equal to f cluster. Again, we're using the function that is in SciPy, distance, and we set it to k. K we already specify as 5, and the criterion here is maximum cluster. Okay, now that we've done that, I'm just going to copy and paste this. Okay, so figure size set, clusters, number of clusters set, and if you plot that, and exactly you've got the exact same result, which is 5 clusters. Now if we set it to 3 as we did earlier, and what do you get? Again, you get the same 3 clusters. So this is probably the easier way that you can actually control the number of clusters that you want to actually have. coming out of it. So that's really the end of these lessons, but we don't want to get away from this here until we actually have done some practice. What I would like you to do now is to actually come here and follow the examples that I did a bit earlier. Now try to actually set this to 50 and see where the cutoff point is and how many clusters you will obtain out of this. Obviously, we've looked at this dendrogram many times. We know what it is, but prior to you plotting the dendrogram, you have no idea. So plotting that, visualizing that, using the truncated mode to actually tell you how many clusters is going to be the outcome and what the distance will be for the number of clusters that you have is very useful. So why don't you actually pause now finally, and including the visualization part. Do that exercise, take a few minutes until you actually become familiar with it, understand what the max cluster here and also the other one, which is the distance here. So try that out, give it a few minutes, and when you come back, I'll summarize the lessons. Welcome back. I hope you actually given that a try. It is obviously very important to help you to cement the understanding. What we cover here is really truncating the dendrogram. We don't want it so massive like this, whereby it doesn't actually inform as much. What we want to do is to see characteristics that actually come together, be it the customer segmentation or be it some sort of outliers. We want to see some sort of patterns, and that's really what clustering is trying to do. In the real world, you are clustering them to actually see some sort of pattern, see some similarity. If you are talking about education, you want to see some student that comes to A, some comes to B, C, or D, and that's really the basic ideas here. And if you actually go to a workplace, if you're on a HR function, likewise, you want to see, what are the good staff that you really want to retain, what are the staff that you find that their performance is a little bit, under the, how do you actually, motivate them a little bit more. And likewise in a business whereby you actually have customers, profitable customers, you want to actually be able to identify them. And this is where unsupervised learning or using clustering really help. And that's really the end of this lesson here. When we come back, we'll move into a different machine learning method, again, unsupervised machine learning method called K-means clusterings. I look forward to seeing you then.